Okay, so this video will be a review of the topics that you need to know for exam 2, along with some hints on what to use or what to put on your note card. So first thing, we're going to start with part 4, which is all the probability stuff. So the biggest thing from part 4, the biggest point total on the test is going to be from that tree diagram, I believe. Don't be mad at me if I'm wrong. It's one of the bigger ones. You know that this is coming. You know you have an example on every test that's up on Blackboard, all 4 of them. It starts with a tree diagram. You have 3 examples done in videos in the lecture notes, and then you have, I think, 2 or 3 in the homework if you want to check out the homework and look at its key. So you have like 10 examples at least of tree diagrams and how they're going to be tested. The only thing I might put in my note card for a tree diagram is the general structure, especially if you're somebody who has trouble with the notation, right? We usually start with splitting up our whole population into 2 groups. Maybe this is under 40 and over 40. Maybe this is, a tuxedo cat, not tuxedo cat, whatever it might be. And then it splits into 2 more. And these are from these groups where we know what's happening. So of the tuxedo cats or of the people under 40, how many have an IRA or don't have an IRA? How many are a jerk or are not a jerk? So having this basic structure down can sometimes help you on the exam, in terms of not having any mistakes in your actual tree diagram notation, and sort of remind you what the heck the whole point is. You could obviously do this with some actual values or with a context in mind, but just this idea that all of our conditionals become ands. We have our conditionals. You may not have to write out this whole thing. You might just draw out a single branch to remind you or remind yourself that whatever we have here as our group is what we know goes behind the line in the conditional, whatever it would be. So you might just need one single branch of this tree. But I do see a lot of students who will try to put A and B as their first split instead of A and A complement and run into a bunch of problems. So some version of this notation to help you out. Once you've finished your tree, remember you're going to use all 4 of the probabilities at the end to do all your work with. And if you want, you could go ahead and put them into a contingency table, right? Having A and B cross and A complement next to each other. So you might want to have that general framework for the contingency table. And then just know there are 4 different probabilities I can ask for. 2 of them I ask for all the time in tree diagrams. That's the other marginal probability. So if I gave you under 40, I might ask about having an IRA. If I gave you tuxedo cat, I might ask you about being a jerk. The other one is the opposite conditional of the cats that are jerks. What's the probability that it's a tuxedo cat or of the people with the IRAs? But of course, I can also ask you and or. So these are all of our different probabilities. And you want to make sure that you know how to do all of them from the tree diagram, and just really take a moment, go through those old exams and verify to yourself that I am very, very obvious on this one. And I always ask those first 2. So if you know the format of the tree diagram, if you have that down and you know how to get those 2 probabilities, you've got a huge number of points in the bag right there. Now, another thing from part 4, we already have a baby version of it, is the other display. This is also going to be worth a ton of points. Contingency table and Venn diagrams. So as you look through the old exams, again, pay attention. I do this question all the time. Usually what will happen is you'll translate everything. You'll have the probability of one thing, the probability of the other thing, and then I'll give you one of the and probabilities. Oh, goodness. I'm going to try to guess at this right now and hope that I don't screw anything up. If I screw something up, it's not my fault. Let's just do 0.1. We'll hope this all works out. And then no matter what, even if I'm having you do a Venn diagram problem, I recommend that you start with the contingency table. We always have our A and A complement next to each other because they sum up to a total of 1. And our B complement next to each other, which again sum up to a total of 1. And then the way these will work is you'll have 3 given probabilities, A by itself, B by itself, and then one of the ands. It could be any of them. In this case, I said A and B complement. And then everything sums down rows and columns. So if 40% are A, then 60% are not. We got 1 plus 3 equals 4. We got another 3 and a 3. I did not do a very good job of coming up with unique numbers, but you get the idea. So this contingency problem, of course, there'll be context with it. You'll see it on the old exams. Maybe you give yourself a table like I did in the notes with the what goes where, or maybe you have the Venn diagram next to it with all what goes where, right? The intersection of A and B, well, that's that point 3, A but no B, B but no A, right? And sort of something where you have kind of both going on in your note card. And then just, again, there are 4 things I can ask you for. Conditionals, marginals, joints, which is the and the compounds, which is the or. Now on this one, if you look back at all the old tests, the things I most commonly ask for are the or and the conditional, because those are the 2 that require you to do a little bit of work with the formulas. So again, this is a pretty straightforward test in terms of the things that I test every year. So if you look back at old tests, you're going to see this is on there every single year. Tree diagrams, contingency tables, Venn diagrams. We also have independent versus disjoint. 2-ish ways that I like to, or 3-ish ways I like to test this, so I'll just run through them. Number 1, A is somebody owns a cat. B is a person, I don't know, is allergic to cats. These are 2 events. And then asking you, are these events independent? Are they disjoint? And then having you give some reasoning and or just choose your answer choice. So in this case, is it possible for someone to be allergic and have a cat? Yes. So I would say that these are joint. There are people who do this. And is there a relationship? Is somebody who owns a cat more or less likely to be allergic or vice versa? And I'd hope that you guys would say that these are dependent, that somebody who is allergic to cats is less likely to own one. So this would be my take on this, is that there's an intersection, because it is possible for someone to have a cat and be allergic, and that they're dependent. If this were the question and I left it open-ended, I wouldn't do this one as a multiple choice because I don't think it's clear cut. Had you told me it's disjoint because somebody who is allergic is not going to own a cat, I would have agreed, allowed you to get full points on that. So disjoint would have been okay here too. But I do know crazy people who are allergic to cats and own one. There are like hypoallergenic type cats and things like that. So anyways, those are the big 3. We do have more. The last 2 topics from part 4. Oh, shit. Sorry. Oops. I mean, for the independent and disjoint, there were 2 more types of tests. So 2 more types of questions. 1 is I give you a situation and I ask you which thing applies. 2 is find probabilities. Oops, find probabilities. So we did this in the Kahoot, and you'll see it as almost the last question of the exam I passed out in class. So I tell you the probability of A is 0.2, probability of B is 0.6, and then I ask you to find A and B if probability, and then I say whichever. So the big thing here is the idea that disjoint A and B is just 0, and independent A and B is A times B, right? And these are probabilities. I'm just being lazy right now. So if you have those 2 things down on your note cards, that these probabilities are where it's at, then you'll be fine. So that's the number 2 way I test it. And then number 3 is sort of like number 1, but with values. So if I told you the probability somebody owns a cat is 0.4, the probability someone's allergic to a cat is 0.1, and I told you that I happen to know the probability of owning a cat and being allergic, well, that's turns out 0.02, very unlikely. You could tell me this is independent or disjoint using math, right? You could actually just use the exact same rules here, and you could say, okay, well, the and doesn't equal 0, so they are joint. right? There is an overlap. There are crazy people out there who own cats and are allergic. And then you could go, okay, well, is this equal to 0.4 times 0.1? No, it's smaller than we expected, which makes sense because, as I said, being allergic would make you less likely to own a cat. So this doesn't equal 0.2. So again, we get a not equal to, and we can say they are dependent. So those are the three ways independent and disjoint are tested. Is this idea of, with just the idea of what they are, could you tell me? With actual probabilities, could you tell me? And then if you were actually told, how does that affect probabilities moving forward? So you'll see those on every exam. You can look through and see that too. There's one last thing out of part 4, which is sampling without replacement. We also covered sampling with replacement, but sampling with replacement technically is just the binomial. It just falls into binomial, so I'm just going to ignore it and we'll cover it as binomial instead. So sampling without replacement, you'll know this is coming because I'll give you some silly list of crap that's inside of something. So there are 5 snakes. I don't know why I'm doing this. Don't know why I chose snakes. And 3 ropes in a bag. Danger noodles and ropes. Suppose you randomly select 2 items from the bag without replacement. So already you know what's going on, even without this last piece, because I've told you about a number of things in a bag. So you're going, okay, snakes and ropes, got it. Now there are 5, I think, different questions I could ask you about this. Almost all of them is going to make your life a lot easier if you just sort of write out what's going on. I got 5 snakes, and then I've got 3 ropes. The five questions, one is, what's probability both are snakes? In this case, we have 2 events that are happening because we're randomly selecting 2 items. In this case, we also, if we want them to both be snakes, they both better be snakes, right? So probability of first one is a snake is just 5 out of the 8 possibilities. But if I've selected the snake, it's now gone. And the next one being a snake is 4 out of 7. Right? The other questions I can ask, no snakes, no whammies, no whammies, no danger noodles. In this case, we'd be pulling rope both times. So this would be 3 out of 8, and then I'm not even going to bother to erase it, 2 out of 7. The last one of these types, exactly 1 snake. This is the one where you need to multiply by 2, because technically I could pull a rope and a snake, or a snake and a rope, and these would both be the same thing. So a shortcut is to just multiply by 2. And then you choose whichever one you want to get first. I usually start with the snake or whatever the thing is that I'm looking for, then pull the rope, the thing I'm not looking for. So in this case, 5 out of 8 would be the snake. That snake is gone. And now there are 3 ropes out of the 7 objects. So all those things multiplied together. So those are the 3 big ones. The other 2 I can also ask, what's the probability of at least one being a snake? Right, 1 danger noodle, at least 1 danger noodle. And the last one is not all being snakes. And both of these come down to the idea of at least one is the opposite of none. So you'll just, whatever you had here, subtract it from 1. And not all is just 1 minus all, which is this one. So just sort of paying attention if we have more than one outcome, that we're just going back to these 3 basic ones and then figuring out how that all works. So that's everything from part 4. I do tend to put on like one tricky part 4 question that might require using the formulas or figuring out what display works. So I always put one extra one on there. You can look through old exams and sort of see where that has fallen over the years. But these are the big sections. If you just knew these, you're like, this is at least a B, if not an A, right here, just knowing these 4 big things, right? our tree diagrams, our contingency tables and Venn diagrams, independent versus disjoint, and sampling without replacement. Really all you need. So then we move on to part 5. So part 5, we went through our discrete and then our continuous distributions, right? So we'll just start with the first of the 4 topics, or 5 topics I guess we have. Discrete probability distributions. As a reminder, these are the things that look like this, where I could write down every possible outcome and the probability of that outcome occurring. And there are 3 things I can ask about this. 1, I can ask you to find a probability. These questions tend to be really easy, right? What's the probability that more than 3? Oh, okay, I care about 4 and everything above that. And then I'm just adding them together. So that's a pretty straightforward question. To me, it's a gimme. Second thing I can ask you to do is to find the expected value, and remember, the expected value is also the mean, or the that is not what I originally mean, or the mean, or the standard deviation. And then this might be something you want to throw into your note card, a reminder of throwing all your x's as L1, all your px's as L2, and then doing 1 var stats L1, L2, where L1 was the list and L2 was our frequency list. And then just a reminder, you want to double check that if you did everything right, n should be 1 in your output. The last thing we might have to do with discrete probability distributions is create one. So see the first page of the part 5 notes. We created one about marbles. This is just sort of knowing this structure that, oops, that is not what we need to see, x and px, and then being able to calculate probabilities. If this happens, it's almost always a sampling without replacement, and then you're just doing these 3 things, right? 0 snakes, 2 snakes, 1 snake. You've got all your different outcomes put into your table. So that's everything we're going to have to do with discrete probability distributions in general. Then we move into the binomial. Should have put binomial beside it. Maybe I can squeeze it in there. That's what I'll do. So binom, don't get too caught up in studying for this. There's a giant cheat sheet. You should not put that whole giant cheat sheet on your note card. It's a waste, because you're probably only going to see 2 binomial questions. First one, is it binomial? And then you're just going to have to know bins, right? What do each of those letters stand for? Other question is finding a probability. There are 2 ways I can ask this, right? I could ask for a single value. In that case, you're doing binom PDF. And the only thing I might put in my note card is just a quick little, if I'm looking at all of this stuff up to n and I just circle 1 number, right? The only thing I care about is 1 outcome. Then I'm just doing binom PDF of 2. P for that 1 outcome. If I do 0, 1, 2, all the way up to our final number, and I circle up to from 0 up to a number, then I'm doing binom CDF, where the last thing I put in is the last digit that we care about, right? And then the last possibility, if I circle the right-hand side of this values, that's the opposite of what binom CDF does. So I'll do 1 minus binom CDF. And my CDF needs to end on the opposite side. So the opposite side ends at 1. I'm doing binom CDF of 1. So that's what I would have in my note card. It's just sort of a quick breakdown of the different things that could happen. If you don't have a good grasp on like at least is greater than equal to, those types of things, you might want to throw that in there. But this is all I would have on my note card. It's just a quick reminder. PDF for 1 point, CDF 0 up to a number, and 1 minus CDF for a number up to n. All right. So that's pretty much everything with binom. I'm going to ask 1 probability question, maybe 2 at most, and then probably an identify is it binomial or not, like we did in the Kahoot in class. So then we move on to continuous distributions. All right, continuous distributions, you'll see at most one of these. This is a situation where I could give you a rectangle and ask you to find an area under that curve, or a triangle. I could even put the two together if I wanted to get cray-cray. But all you need to know is how to find that any probability is just an area under the curve. And then how to find an area from a rectangle or a triangle, and you'll be good. All right, our big, most important thing, this is the biggest amount of points on this exam out of everything I've talked about so far, is the normal distribution. We broke down in class the 3 different questions I like to ask from this. We have our direct question, where I give you some cutoff or region and I ask you what the area is. This is one where we're going to do normal CDF. Lower bound, upper bound, mean, and standard deviation. If you're not good with like whether or not that 999 thing is happening on the left or right or negative, positive, you might want to have all those little cheats down in there. But that's the only thing you need to have is maybe just a quick little note. How did I know it was direct? Oh, you're asking me to find the probability, percent, proportion, something like that. Second type was our inverse questions. This is where we were given an area under the curve and asked for a value from the actual distribution. These were a little bit different. I'm trying to get this thing to come up. I want to be able to move you guys. Yes. And so in this case, you'd use inverse norm with our left area as a decimal, mean and standard deviation. So here we'd get out that value, and in the inverse questions, we would know this value, and we would get out what that cutoff was. And again, I wrote a bunch of stuff on a board. The easiest way to see that you're dealing with one of these is you're going to be given a percent or a percentage or percentile. The last type of normal question was our tricky inverse. These had 2 steps. Step 1 was to find a z-score using inverse norm with our left area and a mean of 0 and a standard deviation of 1, so that we're in the z's, and then to use our formula for the inverse formula to find whatever our missing piece was. And this is where we want to find the mean or the standard deviation. So those normal distribution questions, huge. There's going to be one of each of these, at least usually about 20 points of the exam. So 100%, this is what you need to know about. That worksheet from class, if you're in the hybrid classes, I didn't get a lot of people's worksheets. You might want to, if you're on campus on Monday before the exam, swing by, give that to me so I can go through it and make sure that you've got everything right before you then think you got stuff on the exam. And then one last note here on these two, you will have units. So just be careful. You don't want to lose points over units. And then our very last topic that falls into continuous land was the normal approximation to the binomial. This one's super easy because I have to tell you you're using it. And then it just becomes a regular direct question. So you have 2 steps to this one. Step 1 is to go figure out the mean and the standard deviation for your binomial. These are both on the formula sheet under binomial. And then step 2 would just be to do normal CDF. Now that you've got your mean and standard deviation, you could draw your beautiful curve centered at whatever your mean was and shade everything and just treat it like a regular direct question. So hopefully, I know that was a super fast run through, but I've got everything down that I would put on a note card. You can definitely add more, but this should be your guide as you go through those sample exams. Look through and see that these are the questions I asked. There's always a couple of oddball ones because I want people who really know this stuff to be able to get that A and show that they really truly understand everything. But if you just study the things that are written down here, that's a guaranteed B, if not A. So email me if you have questions while you're studying, but hopefully this helps out.